Hello and welcome to day one of PyCon Italy. So my first time friends for me. And before we start, I want to feel you more secure and make your badge more secure. So I'm rather old, I still remember these devices. So if you look at your badge, there's a small slider on the back end. And if you move that so you can look through the small hole, then your badge is read-only. Nobody can write to your badge anymore. Hi, so I'm Christian Heimes. I'm a longtime Python developer, Python core developer for now 10 years. Mostly work these days on security stuff, so I maintain the SSL and hash model. And work on the Python security team. As part of my day job, I'm working for Red Hat as a security engineer on the identity management stack. So FreeIPA, TOCTOU, Custodia, yeah. So, agenda and goals. So what are you going to learn here and what's the talk actually about? First, we're going to start with the motivation, why you should care about security. A bit of definition, so Wikipedia. Some honorable mentions, so things I can't cover because I'm restricted by time. Bit security bottom up, how you should design your whole stack, starting from the hardware up to the application. And then the biggest part is going to be multiple examples of security issues and bad practices, a bit of summary, and maybe question answer. So I'm trying to keep like 5 minutes, maybe 10 minutes. If you have more questions, you can find me with my white fedora. I'm a white hat hacker. Usually I wear my red fedora, but Italy is just too warm for the red fedora from Red Hat. And the talk is mostly in breadth, though I don't go that deep into specific details, but just want to expose you to multiple ways things can go wrong. But why care about security? It's actually a hard thing. It's expensive to hire security engineers. It takes more time. Well, for me personally, I consider myself as an engineer. Somebody works in public service, like also a proud craftsman, so like somebody like a carpenter, I want to do a good job. But for some people, it's also more about business because it can get pretty expensive. Last year, we had that incident. So Yahoo lost like 1 billion accounts. Well, actually 3 billion accounts. And that got pretty expensive because at the same time, Yahoo wanted to get bought by another company. Initially, they wanted to shove off like $1 billion from the contract. They settled like with 350 million. It's a big sum, but actually not the biggest sum we had in recent history. That's a stock chart from a big company. And you notice here around 16th of March, there's a sudden drop from 185 to, well, $150 per stock. That company had about 2.9 billion shares. So multiply 2.9 billion by 30, 35, it's even larger. So, want to make a guess which company I'm talking about? Facebook. Very good. Facebook. They lost a lot of money, at least on paper. Security is not only about money, it's all about life and death too. There are a lot of ways where security issues can compromise even personal. So that's a good example. A couple of years old, so where there was a pacemaker, so a device implanted in your breast that could be controlled by the doctor remotely to reprogram it. And that is a security issue. And how do you replace a pacemaker? Yeah, you had to cut people open. Yeah. I don't want to be cut open to get a software update. Other thing, also a couple of years, Ashley Madison was a rather shady website to find sex partners if you're already married to somebody, which was also used by non-traditional relationships to find partners. So a couple of gay people used the websites, and there are several suicides connected to that website. And remember, Europe is mostly pretty good shape, but there's still countries where you get killed tortured or thrown in jail for just being gay. So, yeah. And the last little example, I'll let you read that while I get a sip of water. Please obey the code of conduct. There was a company who tried to sell a shirt using the last line where the girl responded, yeah, sure, I love you. That's the correct response. So please be nice and don't be a jerk. But what is actually information security? Good thing is also to start with the Wikipedia definition. So I'll just read that. Information security is the practice of preventing unauthorized access, use, disclosure, disruption, modification, inspection, recording, or destruction of any kind of information. So anything that without information can go wrong. A lot of things. So we want to prevent that something goes wrong. We want to mitigate. It means when something goes wrong, you don't want to lose all your eggs. Some part that's not covered by Wikipedia I find very important is auditing. That means you keep track who's going to access what. And if something goes wrong, you can at least know which part of your infrastructure you have to replace. Recovery, so make backups. That's a good thing. Privacy concerns, that's a big thing for Europe, not that big in the US, which causes some kind of tension, especially. So Facebook, with the recent changes, they moved all the 1.5 billion user data back from Ireland to the US because we changed the privacy laws in Europe. Well, but why is it actually so hard? Why do we get so many security issues? Computers are very complex systems, and there's nobody who actually understands even a part of the stack full extent. And the slightest mistake can cause catastrophic issues. Like you play a Jenga tower, except our Jenga tower is much larger and it's on fire, and yeah. And it's not testable. You can test sometimes for known security issues. You can't test for unknown security issues, and several ones are untestable too. Our software design is rather bad. And finally, there's just too many ways stuff go wrong. Other industries do a better job in analyzing how things can go wrong. A very good example is the aircraft industry. So there was last year was very good. We didn't have any facilities. People died. Nobody died on a plane because of an accident. Even an Air France flight lost his engine over the Atlantic Ocean, a big one. That was just 3 days ago. I read the news article on that flight, that the Southwest flight on the Boeing 737-700. My first flight from Hamburg to Amsterdam going to Florence was also a 737-700. Just one person died who got sucked out of the window, and this plane landed safely. So how we do as an industry software designing? Well, not that good. That happened last year. Some engineers just make a slight mistake and brought down most of the internet because like 1/4 of the internet runs on Amazon, AWS. And instead of shutting down a couple of machines, he shut down basically a whole data center. Well, shit happens. While the air industry does pretty extreme testing, you can't see, so that's the airplane and, yeah, you see better. So that's the hull, that's the tips of the wings. That is a safe, extreme but still safe state for an airplane. Wing up test, so that test that they actually put it correctly together with that kind of, yeah. While we can actually, in the computer industry, even issues that we can use a microphone to get the private key of an RSA operation. Or that one of my favorites, if you like to clean up memory, that's C code, you don't need to understand that. Just here, there's something setting a memory area to 0, but that works depending on your compiler and optimization level sometimes, but if you use a different optimization level or different compiler, the compiler is allowed to remove that because that line doesn't change the output of the function. The compiler says, well, just remove that and still the same output, but yeah. It's very hard to force a compiler to do that, to actually clean memory. I tried to add that to CPython a while ago and eventually gave up because there's no standard way except in the new version of C, but that's not available yet on all platforms. CPUs are very complicated machines. That's a picture I had in my first security talk like 5 years ago, where I told people, yeah, CPUs are dangerous beasts and nobody knows what's actually going on, not even the engineers who built the machines, and yep, I was right. Rowhammer, Spectre, and Meltdown, 3 bugs came out the last couple of years. Rowhammer is just where you hammer against the row of your RAM cells, and via physics, electrons just jump to the next row, and you can suddenly change the security settings of your system just by having electrons jumping between different cells in your hardware. On the other hand, anytime we face to user, we can have that one. User interfaces are very complicated. Languages are complicated. These are 2 different strings. Yeah. So because I read, for example, the Russian R, it looks like a P. So that's one of many ways to detect users. So, honorable mention. So things I can't cover because, okay, 15 minutes, no, 10 minutes in, I think. Yeah, okay. So, stuff out of scope. Legal requirements. So anytime you have to interact like with the EU or with US government organizations, so I write software Red Hat that has to follow FISMA. That's a US law complex for cybersecurity. Data centers, so if you store your data somewhere in a data center, you want to start securing the outer fence, access control, who's allowed to get into your data center, etc., etc., etc. Fire protection, power supply, whatever. Hardware security, how do you actually validate that your hardware hasn't been compromised, parts replaced. Browser, I'm not a web developer in the sense of I don't know what's happening in a browser. Yeah. Ransomware or cyber attacks, state-sponsored attacks, cyber terrorism. Except I want to mention one guy, one of the most dangerous terrorists of them all. Don't trust me? If you go look into how power supplies get interrupted, actual squirrels, birds, and snakes are the most dangerous of them. And humans are just 3 known issues where somebody just messed it up. But especially in the US, squirrels are known to interrupt power supplies and power lines and bring down whole city blocks by just jumping on power lines. Their website is really cool because they have maps and news articles to any incident. You can actually prove that they're right. Human factor is also a big issue. Social engineering. There's something called SEO spam, where just phone the company. Please send money urgent to that company because you want to make a contract. People even give away passwords for chocolate. That was the University of Luxembourg. Dissatisfied customers and stupid, bad management, the biggest issues in social engineering, in my opinion, because if you have some employee who's allowed to access all your private data, all your source code, all your databases, he's able to just download the data and leave the company, and you may be in big trouble for that. Usability, if you make something too hard for a user, yeah, that's an old monitor. If you don't, I'm old, so that's an old CRT monitor and a Xerox, so a copy machine. So someone wants to make a screenshot, and the software didn't allow him to make a screenshot, so they found workarounds. Users always find workarounds. Humans are very good in that. And another thing that's coming up currently is Internet of Things. If you have any device at home, put them in an own wireless LAN, put them behind a firewall, and yeah. It goes even so far. There was a recent incident just a couple of days ago where hackers stole the database of the high road, so the people that spent like billions at a casino using a thermometer in an aquarium. Wow. So, how do you make a system actually secure? Well, start with hardware and operating system, because remember weakest link, and you want to have a stable foundation. So get hardware from a trustworthy vendor. So it means CPU, motherboard, disks, network cards, even cable these days. Network cables, if you have like 10 gigabit network cable, they have firmware and chips in it. You have to validate them all somehow. I don't know how. Even downloading your operating system, so how do you validate that? You need to maybe check some GPG keys, but how do you get the GPG keys in a secure way? That, yeah. UEFI secure boot, although I don't like UEFI, it's still better than BIOS, and with that you can at least prevent that people inject like a bad kernel, so everything is signed and the operating system will not start something that is not signed per trusted key, except if you add machine owner code keys, so mocks. Well, firewall is also a good idea. If you're running MongoDB, you want to now the MongoDB port, or just bind to localhost. Apply updates, and don't disable SLNX or AppArmor. For applications, the same. Especially if you're running in containers like Dockers, don't run your application as root. Restrict access. Try to make small, confined applications that don't able to access all of your data, just small parts. Encrypt, so both in transit, so TLSSL, and on disks, in case your laptop got stolen or somebody breaks in your data center and steals the disks. Bind to localhost. If you have a local application, don't allow anybody to talk to it, just restrict it. That's always helpful, especially for MongoDB. Strong authentication, and finally updates. Really updates. And restart your services after you update, because if you don't restart, then you don't use the new libraries. So build your application like you built forts like a couple of decades ago, a couple of centuries ago. So defense and depth, so every part should protect the other part, and if somebody breaks into one part, should not be able to get to another part. And really update, please. Don't be Equifax. So, now to the examples. Starting with Python. We have a Python conference, and Python is actually a good language because, like Rust and Go, we are a high-level, memory-safe language. We don't have to care about memory management like you saw before, C, which can always get hairy and is a constant source of exploits. But even Python has lots of dangerous features, so even import. So if you download a package from the Python package index and you don't download a wheel but a source binary, so you have to run the setup py, that can run arbitrary code. We had a couple of incidents in the last years, even a couple of days ago, where somebody had like malicious packages on PyPI. C types lets you do unsafe memory operations like in C. Pickle and Marshall also unsafe. Don't accept pickles from strangers. Always validate your pickle. Yeah. Also, API design. If you design your API, especially libraries, you always want to have secure defaults, and it should be obvious and easy to have secure way, and it should be rather hard to run your application in an insecure way. So consistent error reporting helps. Don't have like developer-friendly mode. Start with production-friendly, and have a nice way to have developers have a simple developer mode. Yeah, MongoDB. I've been hit by that. It's better these days, but like 5 years ago. So that's my responsibility. I'm still trying to push that we have cert validation for TLSSL in Python by default. We still don't have that because legacy. Logging. So for one, you want to log when something goes wrong. That helps, but you don't want to log like your passwords or credentials to a log file. So yeah. So running quickly through some examples, what I find regularly in applications I review. File I/O is very tricky. So there's just one example is a directory traversal attack, where you just have a web service where you just download an image. So you get a file name, get the file name put into a base directory, and just stream back the content here. For example, download/image.jpg. If you do it like that, and somebody could do that, read your passwords, read your private keys, so you have to validate your inputs. Other thing is time of use, time of check. So if you first check the file there and then open it for writing, overwriting the file, it can be attacked. So you want to use something like that. Only works in Python 3. Anybody using Python 2 still? Very good. Just a few hands. Good. Python 3, you can have something that the operating system, the kernel, and even the file system driver guarantees that you don't have any conflicts, that you that guarantees to have atomic operations. Either you will succeed and create a new file, or you get an error. You will not be able to just have a conflict in flight. Temporary files and directories, always use a temp file if you run a systemd-enabled system application. So there's something called a private temp, where systemd provides a private area for all your applications. So even /temp is a different thing for every application. File parsing, so just handling data is fun. One bug we had a couple of years ago in CPython is parsing HTTP headers. So that block on the top looks pretty easy. Just iterate over the first line, split them in a colon. So you would have, for example, content type as data. That one looks easy, except it's not, because that one is vulnerable to a denial of service attack. So for line and file means read from the file until you find a new line. So you read like small block, look, okay, no new line, allocate a new bigger area of memory, read again, do that again. And if the attacker never sends a new line, then you allocate like a gigabyte of memory and your application crashes. And that we have CVE 2013-1752 that fixed that. XML, anybody using XML still? One hand, two, a couple of hands. So skip that over. So XML has very surprising features like entities, which can be used to explode. So because A gets replaced a couple times B, that couple of times C, and it gets bigger and bigger and bigger. And you have something called a Boolean laughs attack or entity expansion attack. You can also read from files or web resources, so you can use that to, if you send an XML to a service, then you can use the XML parser to contact private resources in the network of your company. These days it's mostly disabled, but that used to be an issue like 10 years ago. And there's lots of ways XML can go wrong. Or it's most times it's fixed these days, but still watch out if you enable too many features. Translations can even be fun. So we had that in Python 2, a bug in our gettext implementation, because you have in gettext something called plural forms. It means pluralization. Like in English, it's 1 apple, 0 apples, 1 apple, 2 apples, 3 apples, etc., etc., etc. French is a bit different. Celtic language gets more interesting. Russian, I don't know. Anyone speaks Russian? Okay, can we have a word later? I'm just curious why Russian is so complex. And if you have another language called denial of service, then you have like that's n to the power of 1,000 to the power of 1,000. Yeah. And yeah, it gets pretty big number, allocates a lot of memory. And most recent one, came out like a month ago. Yeah, March 4th. A bit more than a month ago, an issue, we had a couple of standard library models in CPython with regular expressions that were running in an asymptotic, very slow case. So if you have regular expression to parse files, be very cautious. The regular expression engine can get to a state where it takes very long time and lots of memory to parse data. So that was the fix. The RFC report explaining the fix in great detail. Don't want to go into that. And even DNA can nowadays be used to attack computers. It's very cyberpunky. So, input validation, probably all heard of Bobby tables, SQL injections. So don't build your own SQL code like that because, yeah, it can be attacked. Please use a proper ORM. If you're a Django user or a SQL Alchemy user, you're fine if you use it the correct way. Same with subprocess. Don't use shell equals true because, well, if you pass that as a file name, then your data is gone. And it's not just SQL and subprocess. A lot of formats, including LDAP, XML, XPath, lots of NoSQL databases, even JSON, if you build JSON not with a JSON engine, what by hand, yeah. TLS SSL in CPython, yeah. That's one of my pet peeves. Please use that construct or request these days to have proper cert validation and validation of the host name. If you need a cert, use Let's Encrypt, or if you need private certs, the software I'm working on, if you'd like to learn more about, it also contains a public certification authority. And keep your private keys secure. Trustico was a CA who got busted a couple of, I think, 3 months ago. They stored the private keys, although they should never have access to private keys. And also, please don't try to roll your own cert validation. I had to fix our Python cert validations a couple of times, and eventually, after very many bugs, there are even more bugs than are listed there. The numbers are bugspython.org numbers, if you want to look that up. So in Python 3.7, I used the new OpenSSL function, which OpenSSL has since 0.02. LibreSSL got it in 2.7. Took a while to get LibreSSL convinced to add the actual function at my bug report. Except they did it wrong. And that was my one day of fame where Guido reported and tweeted my mail to the Python developer mail list. Yeah, and that's my CVE. So they copied code from Boring SSL, so Google's SSL engine, the documentation from OpenSSL, but Boring SSL didn't implement the same code as OpenSSL. So I got like, at the moment, $500 US bugs bounty from Google to look into getting a bug bounty from LibreSSL. And so I felt like a rock star. What do rock stars do? Well, fancy food and drugs. Yeah, that's strong opioids and very fancy, very expensive food for my sick cat. He got an inflamed, infected pancreas. It's very painful, and yeah. But he's getting better now. So we're also able to come. I was really afraid I wouldn't be able to come soon. Okay, 5 minutes to go. So last part, cryptography. So first rule, don't implement your own crypto, please. It can go wrong in so many ways. Even professionals get it wrong. As an example, by Filippo Falsorda, I probably pronounced his name completely wrong. He found a bug in Go's implementation of a elliptic curve crypto implementation. They got it wrong in 0.00003% of the cases, which was still good enough to extract the private key by just talking to the service and sending them problematic data. Yep. On the other hand, if you want to learn more about crypto, please do implement your own crypto, but don't use it in production. It's a very good way to learn. So if you just implement your own crypto and then send it to a coworker or a friend, let them look through, or look how other people did the same mistake. I learned a lot. So, related to crypto, also random number generators. Please use a proper random number generator. If you use random.random your code, and it's used for anything related to security, so like passwords, salts, cookies, whatever, you have a dangerous security issue. You have to use a proper cryptographic secure pseudo random number generator. That's CSPRNG, a long word. So in Python, you have OS random. So Victor, I think I saw you here somewhere. Over there. So that guy helped to make OS random even better. Thank you. If you use Go, crypt random is good. Linux got a system call a while ago after the OpenBSD, FreeBSD people complained. OpenBSD people complained. That used the kernel, and that's actually the only secure way to get cryptographic secure random numbers. For passwords, use any of these algorithms in that order. So that's in Python. I added that a while ago. bcrypt is not in Python, and argent2 is too new. I may add it to Python, but there's a library from Henrik Schlabach. Yeah. And use a constant comparison operation. So don't use like password equal hash. Use that special function because it's constant time. So the runtime doesn't depend on the actual values, which is very important. If you don't need passwords, or try to avoid passwords, try to use some of these services if you can, and please don't use just Facebook like PyCon Italy. I don't have Facebook, so I had to still use my password, create an account with a password for PyCon Italy website. Try to use a couple of them. So I think most developers these days have at least GitHub or Twitter. Or the service I'm working on also does that. AES and RSR, don't use that directly, because if you do that and encrypt your logo, so that's not the logo from the PyCon here in Italy. That's logo we first gave that talk. So you can still see the structure. That's encrypted with AES, but the structure is still visible. So you have to use the correct mode. Can you read that for a second? ECB mode is the bad mode. The other ones are okay depending on the use case. But even if you use encryption, encryption does not protect your data from anybody modifying your information. So you have to use something that protects your data. That's called hashing and MAC. But if you do that wrong, you can also get busted. So some people think if you use a modern version of AES with a Gauss counter mode, that's also safe, except that one requires something called a nonce, which when you do that wrong and encrypt two images with the same nonce and key and use a XOR of that, then you can still get the data back. So don't use bad crypto. If you have to use crypto, it's even better to use packages that provide a high-level API, and I recommend using any of these. Lipsodium is really nice because it doesn't give you much options. It just gives you secure options. And if you have to interact with raw crypto, the Python Cryptographic Authority cryptographic package is very good. PyCrypto, I wouldn't use that anymore. And also take care if you handle secrets in your applications. Yes, if you use like nfras or command lines, yeah, then you're out. So, and most importantly, don't hardcode keys. So, summary, before we come to questions and answer, because, so do that. and you want to get in touch with me, so the email address and Twitter handle, and you need some good books, I highly recommend these 2 books. And I'll let that slide on the screen for a couple minutes and now take questions and answers for another 5 minutes.
Question time. First one. Don't be shy, please. What was the, how can I say, the most difficult security issue that you find in a company or somewhere that you do not solve, or that you have solved?
The most difficult one is actually getting CPython to default to cert validation by default. I'm still trying to do that for a couple of years ago, because lots of people expect that if you just create ASL connection, that Python doesn't do the verification by default. In order to do verification by default, we have to change some settings, and then run into the issue that we don't have access to a public trust store, so the list of all trusted root certificates on all platforms. It usually works fine on Linux and on BSD. For Windows, I added a hack that works 90% of the time. Unless you have a brand new system, then you might get unlucky, because I just use all the known certificates from Windows. But Windows doesn't have all certificates immediately available, so it downloads certificates in the background anytime you access a certificate that uses a root CA, so a trust anchor, the root certificate. And if you get unlucky, you hit a server that you don't have the root CA yet, although Windows would have downloaded it, but I don't use the proper Windows APIs. And for Mac, yeah, Apple doesn't offer a API to get the keys in a way we can use. There's a complex way. Apple has different APIs. There is the POSIX API, then the next step, Carbon APIs. And the APIs I would have to use are not fork safe. So you can't use the fork system call anymore, because then you would crash your application.
So we have another couple of minutes for the last question. Don't waste time. Any other question? Okay.
First of all, thanks for the talk. It was really great. I wanted to ask, like, you mentioned a lot of bad scenarios that can go very wrong very easily if you do the wrong thing, and it's really hard to keep even those in mind every time that you develop something and every time you ship code to production. So do you have any maybe approach how to remind yourself of basic security issues when you develop things, like a checklist that you would recommend, or like how do you normally follow up on all these potential loopholes when you do development in your normal life?
Yeah, okay. So twofold the answer. So one thing is don't try to reinvent the wheel. Reuse existing libraries that provide you a high-level interface for like doing network connections or for storing data in a secure way, or even against SQL injection attacks, use SQL Alchemy. So don't write your own don't write your own libraries. Try to reuse existing libraries when there's good libraries available. That helps a lot to avoid common issues. The other thing, how I actually keep track. I follow a lot of people on Twitter. So there are a couple of crypto nerds I follow on Twitter. I have a couple of RSS feeds I follow, and I'm on a IRC channel for crypto nerds. Yeah. So just keep my eyes open, and I wouldn't actually call me an expert in that. I've seen a lot of stuff or the other S word, but yeah. Just, it takes experience so to actually know how to spot a security issue. One of the reasons why it's probably hard and expensive to find security engineers.
Makes sense.
Yeah, and it's a very interesting topic, and there's lots of different approaches. I myself just scratched the surface, but yeah.
So that's all, and thank you, Kristen.